everyone. Hopefully you have been watching this series of videos, and we've basically just tried to step by step progressively add in conversion factors and some more steps to learn about converting from grams to moles. And today we're going to look at grams to moles to grams. So like I said, we've kind of been doing stepwise approaches to this, having videos just showing maybe one step, maybe two. Okay, and now we know that we can look at a balanced equation and we can relate what's in an equation by its mole to mole ratio. So that's going to be super important. But here's what we're going to do today. I want to give you just sort of a run through first. Okay, we have 3 steps to this problem that we're going to work. Actually going to work 2. And you're going to first convert from grams to moles. If you've watched the previous videos, to get from grams to moles, we use molar mass. And we actually divide by molar mass to get to moles. And then we're going to convert from moles. So this is what we're given, or are known, okay, or given in the problem. And we're going to convert from mole to moles of what we know or what we're given. Our second step is going to be the new step we learned a couple of videos ago. And it's going from moles of a known compound, the one that you're given in the problem, to moles of a different compound. To get from moles of what we know to moles of a different compound, this is where we use our mole to mole ratio from the balanced equation. Okay? Once we have moles of this compound we're looking for, then we convert to grams. So it's just the opposite of this first step. So here's step 1, step 2, here's step 3, and here we're going to multiply. Oops, always does that to me. Okay, we're going to multiply times the molar mass. Okay, so that's just a run through. Okay, and we're still going to, the way this works out and how this is planned out, okay, it's planned this way so that our units cancel, just like we've been doing. The units has to cancel and the compound in order to convert to a different unit. I also want to say that in this first step and in this third step, mole can only be 1, because whenever you go to the periodic table and you add up molar mass, it's always out of 1 mole. Okay, so it's always 1. The only time moles can be more than 1 is in step 2, when you have a mole to mole ratio, and that's when you look at your balanced equation and you see what your coefficients are. Okay, so this is the plan that I just kind of wrote out. Okay, if you have grams of a reactant and you want to go to moles, then you're going to use your molar mass conversion factor of grams per mole. To get to moles of a reactant to moles of a product, so a different compound, you use your mole to mole conversion factor, and this is from your balanced equation. Then to get to moles to grams, we use molar mass again, but it's just going to be turned upside down, or turned differently from our first step, because our units have to cancel. So here you will multiply times molar mass, and here you divide. So that's our plan. so let's go back here. I showed too much. What I want you to see is everything here is a 1-to-1 to 1 ratio. We're still going to show all the steps even though it's a 1-to-1, but obviously you can have a 1-to-2, a 2-to-3, or whatever it might be. All right, we were given in the problem that we have 14 grams of C2H4. So we write that out. We write out our units, grams C2H4. To get to moles, we have to use the molar mass. So we add up the molar mass for C2H4. If you need a review on that, go back to the video that says calculating molar mass. All right, so C2, 2 carbons plus 4 hydrogens gives us about 28.1 as our molar mass, and that is always out of 1 mole. Okay, so there's our first step. These cancel. I'll show that in a minute. So then our next step, we go to grams to moles, so we just did that there. Now we go from moles to moles, okay, of C2H6O. So in the problem, if you need to go back and look at it, in the problem it gave us 14 grams of C2H4, and it wants us to find grams of C2H6O. So that's our product here, okay? We plug in our mole to mole ratio. Here it just so happens that our mole to mole ratio is 1, so it doesn't change really the equation at all, even if we had left it out, but we still want to show it, okay, because oftentimes you will have different numbers here. You'll have 2 or 3s or whatever, and so it changes the answer, changes your final product. All right, moles cancel. We have to have mole C2H4 on the bottom, and then we put moles of what we're looking for. So this is our mole to mole ratio, and we plug it in so that C2H4 cancels with moles of C2H4. Okay, now we just add one more step. So in the previous video, we started with moles and went to moles and then to grams. So here we start with grams, we go to moles of a different compound, and then we go to grams. So in 1 mole of C2H6O, to get from, so we went moles to moles, that's right here, grams to moles is here. To go from moles to grams of the same compound, then we multiply times the molar mass. So we add up the molar mass for C2H6O, and it's 46.1. So we multiply 14 times 46.1 divided by 28.1. Okay, everything cancels nicely, the unit and the compound, because we're converting from one compound to a different one using our balanced equation. And our answer is 23 grams C2H6O. That's the mass of the product. So we have 3 steps: grams to moles, moles to moles, moles to grams. Okay, so we're going to practice another one. Make sure we've got this. We always write out what we know. Okay, and we could do this problem with any of the compounds or elements in the equation. So you just look at the problem and see what it's asking. Okay, so we go from grams to moles. Okay, so that means grams, so I know how to set this up. Grams has to cancel. So to get from grams to moles, I use molar mass. So I go to the periodic table and I add up 2 irons, 3 oxygens, and you should get roughly this. If I use the periodic table to add up a molar mass, it is always out of 1 mole. Okay, so I went grams to moles of what I know. That's what I know is what I'm given. Now, the only way to get from moles of a compound to moles of a different one is using your balanced equation. So if I have moles here of iron 3 oxide, I have to have moles of iron 3 oxide here in the denominator so that these can cancel. Okay, so I look at my balanced equation. I have 1. There's an understood 1 there. Now I'm trying to find, here it's not my product. Here I'm looking for how many grams of the reactant do I need. So 3 moles CO. I have a 3-to-1 ratio, and it's plugged in that way so that my moles will cancel. So I went from moles to moles using my balanced equation. To go from grams to moles or moles to grams, so here's just grams to moles, and then here's just moles to grams, okay? You use molar mass. We divided by molar mass here, okay? So now we're going to have to multiply. We're doing the reverse. So 1 mole of CO, there are, if you add up the molar mass of CO, it's about 28.01 grams. So my moles cancel, and I get about 76.8 grams of CO. Notice, my first step, mole is always 1. My last step, mole is always 1. Okay, the only step where moles can be anything other than 1, it can be 1 just like our previous problem, but here we have a 3-to-1. Okay, and this could be a multitude of things there. Okay, so this is grams to moles, moles to grams. This is one of the most popular, most common, most biggest staple for your general organic chemistry classes, is to be sure that you understand how to do these. So you hear grams to moles, moles to grams a lot. So practice these, and I will see you soon.